Hi folks, Dr. P here. This is Trigonometry 2. So in this question, we are given the shorter side of a rectangle to be 5.7 centimeters long. The angle between this side and the diagonal is 64 degrees. And then they want us to state the answers to nearest tenth of a centimeter. And here they're asking us in question number 1, determine the length of the rectangle. In a question like this, the first thing we want to do is draw a sketch of, in this case, it's a rectangle. We're going to draw our rectangle here. And then they're telling us that the shorter side is 5.7 centimeters. So this side here is 5.7 centimeters long. Then the angle between this side and the diagonal. So the diagonal here, let's go into a different color here, going to be, there are of course two diagonals, but the one I'm going to draw is this one here. That's my diagonal. And they're telling you that the angle between the side and the diagonal is 64 degrees. So this angle right here is 64 degrees. And then in question 1, they want us to determine the length of the rectangle. So this is going to be the length. I'm going to call that L. In question 2, they're asking us to determine the length of the diagonals. That's going to be, I'm going to call the diagonal D. Okay, let's start with question 1. So if we take a look at what we have a triangle here. Highlight the triangle. We have a triangle like this. And then the diagonal is essentially the hypotenuse is that in the triangle, in this triangle, this angle here is going to be a right angle. We know that because it is a rectangle. Okay. And in this triangle here, we know the length of this side here. We know this angle here. And in question 1, we're looking for the length. So in relation to this angle, this side here will be referred to as adjacent. And the length, that side over here, in relation to this angle will be referred to as opposite side. And now the question is, what trigonometric ratio is defined in terms of adjacent and opposite side? Well, that will be tangent. So tangent or tan of angle theta is defined as opposite, the length of the opposite side, divided by the length of the adjacent side. Now we can plug in what we have. We know the angle, so we're going to go tan. The angle is 64 degrees. The opposite side, we don't know what the opposite side is. It's the one we're looking for. We're calling it L for length, so we're going to replace that with an L. And then the adjacent side is 5.7. And now all we have to do here is solve for L. We want to get L on its own. So we can start here by multiplying both sides by 5.7. Whatever we do on the left-hand side, we have to do on the right-hand side. 5.7 divided by 5.7 on the right-hand side just cancels. So we're left with tangent. Actually, I'm going to flip it around. I'm going to write it like this instead. So we're left with L equals 5.7 times tangent 64 degrees. And now it's just a matter of running this through a calculator. And if we do that, we find out that the length to the nearest tenth of a centimeter is 11.7 centimeters. In question 2, we want to find out the length of the diagonal. So in relation to this angle, we still have the adjacent side. We now also know that the length here is 11.7 centimeters, so we could use that as well. And that's still opposite side. This side here, the diagonal D, would be our hypotenuse. And what I'm going to do here, I'm going to be using the adjacent side and the hypotenuse, and I'm looking for a trigonometric ratio that is defined in terms of adjacent side and hypotenuse, and that would be cosine. Cosine of an angle theta is defined as the length of the adjacent side divided by the length of the hypotenuse. We plug in what we have. We know that the angle theta is 64 degrees. The adjacent side is 5.7. And the hypotenuse, we are calling that d for diagonal. So here, what we want to do is we want to solve this time for d, for the diagonal. So we can start here by multiplying both sides by d, because d is in the denominator, so that's a bit of a problem. So by doing this, multiplying both sides by d, we are moving the d out of the denominator. So on the right hand side, d divided by d just cancels, and now we're left with d times cosine 64 degrees equals 5.7. And to get d on its own, all we have to do is divide both sides by cosine of 64 degrees. So on the left hand side, cosine 64 degrees divided by cosine 64 degrees just cancels. And now we're left with d equals 5.7 divided by cosine 64 degrees. And if we run this through our calculator, we're going to get the diagonal to be 13.0 centimeters. That's a wrap. Until next time, stay safe, stay healthy, and may the math be with you. See ya.